Good evening. Welcome in daily UPSC editorial audio program. Now the headlines. New phase. NISAR has capped a decade-long bilateral effort of NASA and ISRO. The GSLV F-16 mission lifted off from Sriharikota on July 30, placing the NASA-ISRO synthetic aperture radar NISAR satellite into a sun-synchronous orbit. The ascent capped a decade-long bilateral effort and opened a new phase in global Earth observation cooperation. NISAR is a 2.8-ton observatory that combines a NASA-built L-band radar with an ISRO-made S-band radar, also a first. They also NISAR to detect surface changes measuring only a few centimeters, even though clouds and vegetation. NISAR will supply freely accessible data on ground deformation, glacier flow, biomass, land use changes, and sea ice dynamics. As its dawn-dusk orbit repeats every 12 days, its radar will be able to revisit the same point under nearly identical lifting conditions. This geometry, coupled with a duty cycle exceeding 50% in the L-band, has been designed to yield closely spaced time series observations that can quantify geological process. Indeed, its various engineering first lead up to NISA's usually broad sense broad science agenda: map mangrove extent, urban subsidence, crop-soil interactions, and calving rates in polar ice shelves in a single orbit cycle. It, its data could help support the Sendai framework on reducing disaster risk and refine IPCC models. For ISRO, flying a flagship payload on the GSLV Mk2 rocket is notable for a vehicle once dubbed "Naughty Boy" early caster for its early career setback. The ISRO-NASA partnership would also ease technology transfer between the two countries. Developing the S-band radar would have demanded tighter tolerance in radio frequency electronics, thermal stability, and data throughout than previous Indian satellites. From a diplomatic standpoint, the launch confirms that India can be trusted with high-value hardware and demanding integration schedules. Although it is still learning to shape joint mission on equal terms, the 12-meter reflector, the Ka band downlink, and much of the flight software stack were imported, and the key design reviews were led by NASA. Achieving parity will require larger domestic investments in advanced materials, deep space communications, and system engineering, plus earlier Indian involvement in framing the scientific agenda for future multilateral missions. NISA's data downlink rate also present a challenge. ISRO must expand its Ka-band ground network, automate cloud-based processing, and release analysis-ready products within hours if state agencies are to make timely use of the data. Sustaining the time-wise data will also depend on authorizing follow-on SAR spacecraft before 2030 and finalizing data sharing rules that encourage private analytics while protecting sensitive scenes. Addressing these gaps will determine how fully NISA's potential is realized in India. Thank you. Stay tuned for next Hindi editorial audio program.